Amplitude modulation. Let us visualize it. This is the video which gives the information about basics of communication model, need for modulation, what is modulation, and gives the detailed information about amplitude modulation. Apart from this video will also help you to write MATLAB code for amplitude modulation, let you know the conditions to be satisfied in amplitude modulation, and explains the necessity of modulation through MATLAB code and graphical user interfaces. So let us start from the basics now. Communication is the process of transferring the information from the source to destination. Nowadays, we are having many devices which can be used to transfer the information over the longer distances, and the information may be audio signal, text messages, videos and pictures. So communication is the process of establishing connection between source and destination to transfer the information, and the communication model contains source, transmitter, channel, receiver and the destination. Sources and destination are the person who are going to transfer the information. Transmitter and receiver are the devices which is responsible for transferring the information, and the channel is the medium which may be either wired medium or the wireless medium. In real world, the channel didn't transfer the information from the transmitter to the receiver as it is. Instead, it adds some noise along with the information. Modulation happens at the transmitter side and demodulation happens at the receiver side. What is modulation and demodulation? Let us see down the line. Now, let us assume that a person is having an audio information and he need to convey this information to the destination through his mobile phone. Now, this mobile phone acts as a transmitter, and this transmitter is responsible for converting this information into a suitable form for transmission. The human audio frequencies ranges from 300 Hz to 3.4 kHz, which is of low frequency range. When this low frequency signal is transferred over the channel, it creates some issues. First, let us see what all the problems occur when the signal is transferred as the low frequency signal in the channel. We know that at low frequency, the wavelength of the signal is large. The height of the antenna is directly proportional to wavelength. So at low frequency, the required height of the antenna is large. The second one is energy of the signal. The energy of the signal is directly proportional to the frequency. So at low frequency, the energy is less. This leads to poor reception at the receiver side. And the third one is power radiated by the antenna. The power radiated by the antenna is inversely proportional to the wavelength. So the power radiated is less in case of low frequency signal. In order to overcome the drawback of low frequency signal, this low frequency signal should be converted into a high frequency signal, and this process is called modulation. Modulation is the process of changing the low frequency signal into a high frequency modulated signal. This is done with the help of modulator. The modulator takes the low frequency message signal as the input signal. It converts this low frequency message signal into a high frequency modulated signal with the help of another one high frequency signal is called as carrier signal. The carrier signal is the high frequency signal which carries the information of the low frequency signal, and the high frequency carrier signal is varied in accordance with the amplitude value of the message signal, and it is transferred over the channel as a modulated signal. Now let us define what is modulation. Modulation is the process of changing some parameter of the high frequency carrier signal in accordance with the instantaneous amplitude value of the message signal, and the parameter may be amplitude, frequency and phase of the carrier signal. Now, because of modulation, a
According to the instantaneous amplitude value of the message signal, the carrier signal is varied and this signal is called as modulated signal. This modulated signal is traveled over the channel. At the receiver side, demodulation happens. Demodulator extracts the information of low frequency signal from the modulated signal and this process is called demodulation. So demodulation is the process of extracting the low frequency message signal information from the high frequency modulated signal.
The disadvantage of transferring the signal as a low frequency signal in the channel can be overcome with the help of modulation and demodulation technique. So with the help of modulation, the required height of the antenna becomes small, the energy of the signal becomes higher and it improves the quality of reception and the power radiated by the antenna becomes more. Apart from these advantages, the modulation techniques have some more advantages also. It avoids interference of the signal, that is, the mixing of signals can be avoided. And the next one is a single channel can be used by multiple users, so multiplexing is possible. There are many types of modulation techniques. In this video, we are going to see about amplitude modulation. Amplitude modulation comes under the category of continuous analog modulation, in which both the input message signal and the carrier signal are the continuous signals, that is, it varies with respect to time. And in amplitude modulation, the modulated signal has the frequency of carrier signal and it varies in accordance with the amplitude of the message signal. So the parameter is amplitude. The amplitude of the carrier signal is varied in accordance with the amplitude of the message signal. Now, let us see the definition for amplitude modulation. Amplitude modulation is the process of changing the amplitude of high frequency carrier signal in accordance with the instantaneous amplitude of the message signal. So, whenever the amplitude of the message signal is higher, the modulated signal have higher amplitude. Whenever the amplitude of the message signal is lower, the modulated signal have lower amplitude. Now let us see what happens at the demodulator section. The demodulator gets the amplitude modulated signal. From the amplitude modulated signal, the envelope of the amplitude modulated signal can be extracted to get the original message signal. In this picture, the first signal is the low frequency message signal. The second one is the high frequency carrier signal. The third one is the amplitude modulated signal. In the amplitude modulated signal, the envelope is traced out to recover the original signal, which is called as the demodulated signal. This happens in the receiver side. Mathematical representation of amplitude modulation, condition to be satisfied for amplitude modulation and its MATLAB code will be continued in part 2. Hope you enjoyed this video. Thank you for watching.